We'll label the points A, B, and C. And then what's the equation for a plane that we like to use? A times what? Yep. Plus B times, yep, y minus y naught plus z minus z naught equals 0. Right. So we need to find a vector that is perpendicular to the plane. So to do that, we use cross product between two non-parallel vectors in the plane. So let's just do, how about AB and AC? So A to B, what's that going to be? -5, -3, and -2. Is that correct?
Yeah.
Yeah, tell me if I'm getting this right. AC, what do you get? -3, then what? -2, and then what do you need to do now? You need to do AB cross what? AC. Could you do the cross the other way around if you want to? AC cross AB?
No.
Yeah, you can. So if you have a plane, you cross two vectors. I didn't actually go over this. This is a good time to go over it, actually. The right-hand rule. So let's just go over that briefly. So let's say you have two vectors in 3 space like this, V and W. This right here is V cross W. That one right there is V cross W. This one is what? W cross V. How do you know which way they go? You put your hand on top of the starting vector and you curl your right hand towards the second vector, and how your thumb is pointed is the direction of the vector. So if you were crossing W cross V, you would start like this, curl your hand, and what direction is your thumb pointing in? Pointing down. But if you started here on V and you curl your hand, your thumb is pointing up. That's how you figure out what direction it's going in. You can use either one. Either one will work. Does that kind of make sense?
Do you always have to curl anti-clockwise?
No, you always curl from the direction of the one you're starting with towards the direction of towards the second one. So V to W means you start here, you put your hand here, and you curl. You put the side of your palm there and you curl towards it. So if you had the two vectors here, like this, let's say that this is V and this is W, you put your hand on top of this one and curl towards it, thumb is going up. But if you're going the opposite direction, it's always this edge of your right hand. Edge goes right there, you curl, and it's going down. Everybody's got that regardless? Okay. So you could use either, but let's do it this way. So what do you have to find? How do you set this up? Can someone tell me what the grid is? What do I put across the top?
IJK.
Yeah.
Where are you curling towards?
You curled from, I'm curling from, on this picture?
Yeah.
From the first one to the second one. So from this to that, or from W to V.
You have to know V is W's first.
The first one. You go from the first one to the second one, from the first one to the second one. So this right here, that vector is W cross V, and this one right here is V cross W. So we go back here, IJK, and then what do we write? What's A? -5, -3, -2, -3. What do you think the most challenging thing is in terms of, where do you think the highest frequency of mistakes is going to occur? The sign. You're going to mess the sign up, right? And it's going to go, wah! So do you understand that setup right there?
Yeah.
Are we okay with that?
Yeah.
It is really tempting to go really fast on this, and what is most likely going to happen? If you just fly through it, you will make a mistake. I literally have okay, I'm going to go like this. So what do I have here? I have -3 times -1 minus -2 times -2, and that's times what? I. And then what do I subtract? What's the oh, I can erase this nicely, right? Circle the J, that goes away. What do I end up with? -5 times -1 minus what? -3, and that's times what? J. And then I have parentheses. I'm going to erase this again. Set up the next one. Here, that one goes away, and what am I left with? -5 times what? -2 minus -3 times. And is it really easy to get these wrong? Absolutely. I'm going to do these real careful. I just left myself no space. Good job, Josh. So let's just pause this for 1 sec. Become, well, do it piece by piece. Be very careful if you don't. We're just always very careful. What do you end up with? You end up with 3 minus 4i, correct? Minus what? 5 minus 6j, and what? 10 minus 9k. So what vector is that? That vector is going to be -1 comma what? 1 comma what? 1. The negative becomes a you got the negative out front. So you have -1, 1, 1. So you go back to your formula, and what do you now know? A is what? B is, C is, and then you just have to pick A. How about, which one do you want, 3, 4, 2? Sure. So what do you get? You end up with -1 times x minus 3 plus 1 times what? 4 plus 1 times z minus 2. That's the point. 3, 4, 2 equals what? 0. Now you might have, if you compared your work with somebody else, they might have picked a different point. They might have crossed the vector a different way. How can you check to see if you have the exact? Yeah, you multiply that. Negative x plus 3 plus y minus 4 plus z minus 2 equals 0. So you have negative x plus y plus z negative 1 negative 3 equals 3. Is that correct?
Yeah.
Think so? Yeah. So that would be the same. No matter how you did it, you should end up with that same form right there. Chip, yeah.
So you can use any of.
So the base is a what? B cross C, not B cross C, but BC defines a parallelogram, right? Do we know how to find the area of that base? Yeah, how do you find the area of that base? It's the magnitude of the cross product. So if you cross B and C or C and B, and you take the magnitude, can you find the area of the base? The formula for a parallelogram we're going to use is literally base times height. You can slide that top around, right? What's the area of a triangle? 1/2 base times height, right? So if you have the same base, right? If you had this same base right here, but then you did this triangle, and then if you did this triangle, all these triangles have the same what? They all have the same what?
Areas.
Exactly. Same thing is true with the parallelopipeds. If I took this roof and I slid it around on the plane, will the volume change? No. If I took this and stretched it, the volume stays, it gets skinnier and skinnier, it gets longer and longer, volume stays the same. The area of a parallelepiped is base times, is the area of the base times the vertical height. Okay, so I crossed this out because I just want to label it H, right? But what is the volume going to be? It's going to be this volume, this area times H. Do you agree with that? Okay, so let's do a little bit of calculus here. Well, we know the volume I just told you is base times height. Are you good with that? Oh, there's this right here. If you know this angle measure right here, you see theta right there, everybody? See that?
Yeah.
What's cosine of that angle? H over what? The magnitude of A. Are you okay with this? Are you okay with that? Cosine of that angle is H over the magnitude of A, and we're going to get to it too. So, therefore, what does H equal? Magnitude of A times cosine of theta. Are you okay with that so far? Are you okay with that? Yes? Raise your hand. Are you okay with that? Good? Everybody hears me? Okay, so what is this? What is that right there is the height. Do you agree? What's the base area? The base area is the magnitude of B cross C, correct? Do you agree with that? So what do you have here? First of all, just look at B cross C. Ignore everything else. You with me so far? Mm-hmm. When you cross two vectors, what do you get? A scalar or a vector?
Vector.
Do you agree with that?
Yeah.
Okay, so B cross C is a vector. A is a, A is a vector, but just A is a vector, right? That's the magnitude of, so this is a magnitude of a vector times the magnitude of a vector times cosine, right? What is that?
Dot product.
The dot product of two vectors. It's the dot product of two vectors. So the volume of a parallelepiped is B cross C dot A. B cross C dot, I just explained how. You can read it again. I literally just did. Look, this is a vector, right? This is a vector. What is the geometric definition of dot product? The magnitude of the first vector times the magnitude of the second vector times the angle between them. What do you have? A vector, and an angle between them. So therefore, what is that known as? That is the dot product of this vector and that vector. It is the dot product of two vectors. Of two vectors. This is a vector. Product. Exactly. How do you get this vector? You need to do a cross product to get this vector, but this is a vector and this is a vector. All you're doing is the dot product of two vectors. So if you want to find, or you're asked to, or you're forced to, find the volume of a parallelepiped, how do you do it? You cross two of the vectors and you dot it by the third. That's it. And absolute value, because depending on which direction you cross product, sometimes it could be negative. Magnitude is always going to be positive. Yes, no.
Like in physics.
It was
B cross C.
B cross C dot what? A. So what's the first thing you have to do for 16?
B cross C.
B cross C. Find a part of the board with a partner and do B cross C. Go.